Hello and welcome to Maths 11. Okay, so we're going to continue talking about some of the rules regarding exponents. So the first one is here, a to the m over a to the n, and that's going to be a to the m, and then we're going to flip up the denominator there, and we're going to have that as 1 over a to the n. So yeah. So that's and we could also say, of course, that this is a to the m times a to the minus n. That's another way of looking at it. And of course, we can say as well that that's a to the m minus n. So we add up these two, the power here and the power here, and so m plus minus n, and then a to the m minus n. So they're all the same. And you can also do another root here. We can say that's one to the over a minus m times 1 over a to the n. Similarly, we're going to get 1 over a to the n minus m. So they work the same. So you can see that the reciprocal we're going to have to subtract in the opposite direction. Okay, so there's that. And that's, of course, and that's paying attention to the rules that we had before. With a to the minus n is 1 over a to the n. And of course, some of the multiplication rules as well. Okay, so all right, let's do this then. So a over b to the n. Well, what is that actually equal to? Well, we can imagine what this actually looks like. It's going to be something like this. A over b times a over b times a over b to the final a over b. And if we look at this whole section, there's going to be n factors. So that's the exponent here. So what we can say then is that this is going to be equal to a to the n over b to the n. So it's a times a times a n times, and b times b times b n times b to the n. And yeah, so look back at this top one again, I guess. Yeah. A to the m times 1 over a to the n. And you can see how it follows really. And it really is, it's all based on it's all really based on this. You know, like 2 to the minus 2 is a quarter sort of thing. I mean, it's interesting when you think about the powers of 2, and this is kind of a little bit irrelevant, but I do want to just briefly touch on it. So it's 1, 2, 4, So if we took minus 1 in there, so 2 to the minus 1 is going to be 1 over 2 to the 1. So 2 to the 1 is 2, is 1 over 2. So if it's 2 minus 2, 2 to the minus 2 is 1 over 2 to the 2, 1 over 4. And you can see that when this is minus 1, this is simply flipped over. But yeah, so what else can I say here? Just to add a bit more detail to this. Yeah, so if we look at this then, so say we've got, say we're doing, I'll just do a little bit. Say we're doing 2 cubed over 2 squared. So we would have, well actually I'll do some of these explanations in the next video. I think that would be a recap episode. But yeah, so this is the most important thing I think for getting into polynomials and stuff. And yeah, so of course there's some important things to realize as well. So one of the important things that I spoke about is if we look at minus 2 to the 5 there, well, actually we should do an even power here. It's the 6. It's going to be 64 because it's an even power. But then if we do something like yeah, I did speak about this before, but I want to speak about it again as well, just because I'm going to be doing a recap soon. Just want to get everything clear here. Minus 2 to the 6 is basically the same as saying minus 2 to the 6, like that. So it's going to be, so it's minus 64. So essentially what you can look at is like the brackets, basically the precedence. Oh man, I can't even remember how to spell it now. Brackets first, then powers. So we're saying here we've got this minus 2 and we're multiplying it 6 times. Here though, we're saying we're taking 2, multiplying it 6 times. And that's because this minus, you know, like multiplication, division, addition, subtraction. This is way down the list in terms of operator precedence. So this minus, so once we see this exponent, this is number 2. So there's no brackets here, but we can of course put brackets in to clarify it. So yeah, we're taking this piece here, and then we're putting the minus on afterwards, and that gives it a different result. Alright, so what else can I say? Alright, so let's look at certain things which are not equal to each other. So if we have AB cubed, we can say that's not equal to the quantity AB cubed. And it makes sense because this, well, we could even write out the whole thing. This is basically this. That's what that is. And this put the not equal in again, I guess. Yeah. So yeah, so this is AB cubed, and this is A cubed B cubed. So it's different. It's a different thing. So yeah. So they're not the same. Now that should be pretty clear. I guess I could do that for next few as well, maybe. All right. So the next one is so that's not equal to AB to the minus 1. So AB to the minus 1 is not equal to the quantity AB to the minus 1. So, I mean, what is AB to the minus 1? Well, we could look at B to the minus 1. B to the minus 1. So B to the minus 1 is 1 over B. So it's A times 1 over B. So it's A over 1 times 1 over B. So that's A over B. This one, well, it's AB. So it's 1 over AB. Yeah, you can't actually do any more steps for this one. That's just 1 over AB. But yeah, you can see that's not the. You could see that. So I mean, where can we go with that? I wonder. Nowhere really. We know it's clearly not the same though. Okay, so none of this is the same. So even though the order is the same, the brackets here, the brackets are taking precedence over the power. And whereas in the first one, the power is taking precedence over the multiplication. So there's a difference. All right, and just okay, so let's do, yeah, and like I say, in the next episode I'm going to be I'll do lots more stuff with exponents. I'll probably just do a lot of small exercises with this. Okay, so here's another one. Is not equal to okay, so here we can see again what's going on. So A cubed times A to the fourth power is, remember that remember that A to the M times A to the N is A to the M plus M. So in that case, we simply take the 3 and then we add on the 4. So that's good. This is the same as A to the 7. This one, on the other hand, the brackets take precedence. So we're taking this quantity A cubed. This is the quantity we're looking at. And we're saying we want this to go to the fourth power. So yeah. So what was it? I mean, I think it was A to the M to the N. In the brackets, you could say, yeah, it's A to the M times N. So this is going to go to A to the 12, which of course not equal. And let's do another. Okay. Yeah, and now we're going to do an addition. A to the minus 1 plus B to the minus 1. Not the same as A plus B to the minus 1. Alright, so what is A to the minus 1? A to the minus 1 is 1 over A. B to the minus 1 is 1 over B. So what's this one then? Well, it's just 1 over a plus b. So yeah, so you can see that if a was 3 and b was 4, this would be a third plus a quarter. And that's not going to be the same as a seventh. It's very easy to see how that's clearly the left-hand side is larger. So yeah, the key thing really is this. Exponents do not distribute over a sum. The word sum is actually a very complicated word. Well, it's not a complicated word, but it's a complicated concept. But yeah, so I mean that's really all I want to talk about. In the next episode, like I say, I will be focusing more on various other things that we can do with this. With regards to kind of exercises, looking at this, because once we start moving into more complicated polynomials, it's going to be very, very important that all the work is correct. And I should just look at that top one last time. Yeah. I think most of the focus, is going to probably be on these two.